Imagine you're building a dashboard app where you want to visualize data in real time and in a user-friendly window. Integrating Matplotlib with Tkinter lets you add stunning interactive charts to your Python GUIs, perfect for taking your projects to the next level. By the end of this tutorial, you will have a fully functional Tkinter GUI with embedded Matplotlib charts ready to impress. In this hands-on tutorial, we'll learn how to create a basic Tkinter GUI window, embed Matplotlib charts into the GUI, add interactivity to the chart, update charts dynamically based on user inputs. We'll cover each concept step by step with real-world examples, and I will explain every block of code in detail. I'll be using Jupyter Notebook, but you can choose any IDE you are comfortable with. The foundation of every GUI app is its window. Let's build one and see how easy it is. First, we import Tkinter and give it an alias tk. Then we initialize the main window and set the window's title and size. This keeps the window running until manually closed. Running this code will output a blank GUI window. Adding a static chart to the GUI bridges the gap between data visualization and user interaction. Alright, let's start by importing the necessary modules. Here is the first line. We import figure from the matplotlib.figure. Think of figure as the main container for our plots. It's like the canvas we will use to draw charts on. In Matplotlib, this is where everything starts. Without a figure, we can't plot anything. Next, we import the figure canvas tkarg. The figure canvas tkarg acts as the glue between Matplotlib and Tkinter. We're essentially telling Matplotlib, hey, your figure needs to live inside a Tkinter window. Without this, we couldn't display the chart in our GUI. Now let's create the figure. Here we are initializing a new figure object. The fixed size argument defines the size of our canvas in inches, 6 inches wide and 4 inches tall. If you want a larger plot, increase these numbers. Then DPI equals 100 sets the dots per inch or the resolution of the figure. A higher DPI means sharper visuals. For most use cases, 100 is a good balance. Moving on to the subplot. Here we are calling the add_subplot method on our figure object. What does this do? It adds an axis object, basically the plotting area, to the figure. Now that one parameter is a shorthand notation for a grid layout. It means one row, one column, first subplot. Since we're working with a single plot, this is all we need. If we wanted multiple plots, we'd adjust these numbers. Next, we need some data to plot. Let's define it. Here, data_x represents the x coordinate, basically the position along the horizontal axis. Meanwhile, data_y holds the corresponding y coordinates. For example, the point 110 is our first data point, 220 is the second, and so on. Now let's plot the data. Here, the plot method takes the x and y data and creates a line connecting those points. It's as if we're telling the plot, connect these dots please. The label equals sample data argument is for the legend, which we'll add shortly. It names this line so it can be referenced in the chart. Customizing the chart is next. Let's add some labels and a title. Here, set_title puts a title above the plot. These two methods label the axis. Without them, our chart wouldn't have any context. It's like giving directions without street names. Finally, let's make that legend show up. This method draws the legend box on the chart. Since we labeled our line earlier, the legend will now display sample data. Next, for the Tkinter part. Here is where the magic happens. We are taking our fig and embedding it into Tkinter via figure canvas tkarg. The master equals root argument tells it to place this widget inside our main Tkinter window, which we assume is called root. This renders the plot onto the canvas. Without this line, nothing will actually show up. Finally, this method grabs the Tkinter widget created by the figure canvas tkarg and packs it into our window. Now the chart is fully integrated with the GUI. Running this code, you will see a fully embedded Matplotlib line chart inside your Tkinter window. It's like combining the power of Matplotlib plotting with Tkinter GUI building. This approach is fantastic for creating interactive apps that involve visualization. Static charts are great, but interactivity takes them to the next level. Let's add a button to refresh the data dynamically. First, we define a function to handle the chart update. This line starts the definition of a new function, update_chart. Functions in Python are reusable blocks of codes, and in this case, is a code that will refresh the chart when the button is clicked. The first thing we'll do inside the function is to call the subplot.clear method. This removes everything currently drawn on the subplot. It's like wiping a whiteboard clean before writing something new. Without this, new data will overlap with old data, which would look messy. Here, we're defining a new y-axis dataset, new_data_y. Notice that the data_x remains unchanged. The x-axis values are fixed, but we are updating the y-axis to display something fresh. This means the updated line will connect these new points: 110, 215, 335, 425, 550. Now we call the plot method again, just like we did earlier, but this time we're using the new data and customizing it a bit more. Label equals updated data ensures this new line appears in the legend with the specific name. Color_red changes the color of the line to red, making it visually distinct from the previous plots. Just like before, we're adding the title, axis labels, and the legend to make the refresh chart well organized and easy to read. Finally, this method tells the Matplotlib Tkinter canvas to render itself, showing the updated plots. Without this line, the new chart won't appear on the GUI. Here's the exciting part. We are creating a button using Tkinter's button widget. Let's break it down. Root places the button in the main Tkinter window. Text equals refresh chart is the label displayed on the button, while the command equals update_chart. This ties the button to our update chart function. When the button is clicked, the function is executed, refreshing the chart. This positions the button in the window, just like we did for the chart canvas earlier. Running this code, we will see the original chart displayed in the Tkinter window. Below it, you will have a refresh chart button. Click that button and the chart updates with the new data. Let's add some real-time data updates. Imagine showing real-time stock prices or sensor data. Here is how to continuously update your chart. First things first, we bring in the random model. Why? Because in this example, we are going to simulate real-time data using random numbers. This is just for demonstration purposes. In the real-world scenario, you would be fetching actual data from an API, a database, or a sensor. We are defining a new function, real-time updates, which will handle the real-time updates of our charts. The idea is simple. Every time this function is called, it refreshes the chart with new data. This line wipes the chart clean, just like before. Each update starts with a blank slate, ensuring we don't overlay the new data on top of the old data. Here is where the real magic happens. Let's break this down. This generates a random integer between 1 and 50. The list comprehension creates a list of 5 random integers. The underscore is a throwaway variable. Since we don't actually care about its value, we just need to loop 5 times to generate 5 random numbers. These random numbers simulate live data points for our y-axis. The x-axis remains unchanged, just like in the previous examples. Here, we plot the new data. To make it visually distinct, we have labeled it as real-time data and set the line color to blue. This way, you can easily identify it on the chart. Just like before, we are giving the chart a title and labeling the axis to make it clear and readable. The legend ensures the label real-time data appears on the chart. This updates the Tkinter canvas, displaying the refresh chart in the GUI. Now here is the key to making these charts real-time. The root.after method is like setting a timer. 1000, this is delay in milliseconds, 1 second in this case. Real-time_update, the function to call after the delay. This creates a loop. After a second, the real-time update function calls itself, refreshing the chart with new data. This process repeats indefinitely, making the chart dynamic. Finally, we kick off the updates by calling the real-time update function once. From here, the loop takes over and the chart refreshes every second. Running this code, the chart will start with a blank canvas. Every second, new random data will be generated and plotted, and the chart will dynamically update, giving the appearance of a real-time data streaming. If you enjoyed this tutorial, don't forget to like the video and subscribe to this channel for more hands-on projects like this. In the next tutorial, we'll add advanced features like exporting charts and building a data-driven dashboard.